That's good. Okay. Let's see, can I test? Test. That looks like it's testing good. Here. iPhone. Hey, Matt. Yeah. Can you come help me connect stuff? How do I connect, please? I have a meeting started. I need some help. There's 3 people in. Need some help. Let's see, I got 3 participants. Are they in? Are they waiting? Admit. Need help. I need to connect things. Hearing. I need to connect hearing. Hey guys, can you hear me? Steve, you're on mute.
Okay.
Hey. Oh, good. Yay. And Charles is there. How are you guys?
Yeah, there you go.
My husband. He's right here. Say hi, Matt.
Hey, Matt.
Hey, Matt.
Yeah.
He's sort of disappearing in and out. His
I
know.
got
body kind of thing.
my black screen or whatever.
Yeah.
I got a black shirt on. I don't mix with the green screen.
Yeah.
Sit up here. It goes, well, oh, you got a blue screen now. Do you
There you
actually
go.
have a green screen
Oh.
behind you, Charles?
Yeah, I do. Yep.
That's
It's
cool.
my kid's a film student at at NYU, and he left his come on, stop.
That's
It's
very
gonna
cool.
Stop. There we go. So anyway, so there is a green screen right behind me. Yes, he didn't bring it to school.
That's
So,
There's a startup, and I can't remember the name of it, but they have a professional inflatable green screen that has the lights built in and then AI to compensate for all the shadows and so on. It's really amazing.
You're right.
huh.
We'll fix it.
Yeah, I mean, I had to put it up the other day for, I had to record this thing for the Air Force. So I said, I'll just leave it up a couple days and it's all right. So,
Oh, cool. So, hey guys, I probably shouldn't do full screen because I can't really. I want to test some things if you guys don't mind. I want to get everybody rocking and rolling. First of all, Charles, very nice to meet you. Thank you so much.
same here. Thank you, Shannon, for inviting me. Appreciate that.
Okay, very excited about it. I think we have some exciting people that are coming. I need to watch the waiting room. And Steve, you're going to need to do that too. So let me see, before I start presenting, Steve, can you share your screen and can you let people in? That's a big question. So next person that comes in, I'm going to see if you can actually let them in, Steve.
Okay, it says host disabled participation screen sharing.
Okay, so I need to come in here and look at, not the chat, I want the people. There's a way to do this. Put that up, invite, and no, that's not it. This is why we start early.
Exactly.
I'm going to get my remote. I'll be right back. Excuse me.
Okay. Oh, here we go. Multiple participants can share simultaneously. There you go. Why don't you try, Steve?
Okay, you should be able to see Charles'
Yes.
presentation.
Perfect.
So
Okay.
he sent it to me and I've got it ready to go in case something goes wrong.
Very good. And I'm going to have to send you, well, I don't think I'm going to send you mine. I think I'm going to just give it, but well, maybe I will send it. Invite, mute all, more. I don't know about the waiting room. That's the thing that really makes me nervous because if I can't let people in the waiting room, this happened when I did the HCL one and I was WhatsApping with people in India. It was very cumbersome and I could actually go in, I had to go to their website or something to do it, so.
Yeah, there's no buttons for me. When I host a meeting, I have 3 buttons and breakout rooms and a whole bunch of stuff comes up and I don't have that.
Well, here's the thing is this is not the professional one. This is the $100 a month one. So let me see more. Let's see, ask all to unmute, mute all upon entry, play, join, and leave sound, lock meeting, allow participants to unmute, rename, and start a video. I don't have the waiting room. So I think there's something, where is that? It was like in zoom.com or something. Let me look here. Go to Zoom. Oh, there's Zoom. And was it support? Let me go to Zoom support. Okay. Oh gosh. Join a meeting, contact support, sign in. Let me sign in.
Charles, do you want to try to share
Sure.
while Shannon's scoping things out? Beautiful.
Yeah.
We're good.
I'm really, really happy we're using Zoom because I mean, Teams has just killed me, you know, I mean, it just never works. I gotta use it on my I can't use it on my laptop at all.
Oh my God.
So this is, you know, flipping through stuff. So,
Yep, looking good.
okay.
The only thing I'm worried about is that meeting room. So I'm going to look for my WhatsApp app. Actually, I can put it in here, WhatsApp. There it is. I'm going to see if I can go find the thread.
Yeah.
Hey,
I might give you my Bradley Zoom account, as long as you promise only to use it for the IoT meetups, that we have full functionality.
that would be great. I think,
Yeah.
you know what, I think Andrew's got one too. So let me see here. Okay. Oh, here we go. Daily backup history. Okay, let's do that. Okay, do it weekly, whatever. Next. Oh gosh, just everybody stop. Okay, it would have been from Parnama. Parnama was my lifeline. There will be a Zoom folder in there. Just trying to do that. There should be a saved chat. Got that. What seems to be the issue? Maybe you can share an image. Oh gosh. Okay, tell you what I'll probably do is let's go through the presentation first so that you guys are cool with it. I'm going to pass it, Steve, to you. Okay. Let me do that now just to make sure if I have to say like, hey, this is Shannon, I'm passing it to Steve now. So that because I have dinner plans. And it should be, the meeting should be recorded. I said record it as soon as we started. So let me go into email.
It's recording now.
Yep, it should be. We're gonna have all the bloopers on this. Sorry, guys. And then I'm gonna have to figure out, we can't really publish it until make sure I don't have anybody in the waiting room. Okay, I don't think I do. Okay. I'll have to figure out for publishing how to edit. And there's lots of people that know how to edit. I'm just bad at it. Okay, let's see. Steve Peoria. Okay. And this is the IoT meetup. Thank you, autocorrect. And just let me go ahead and attach. File, every app attached file. I have been in so many different applications. It's really frustrating. Documents. We are in there. Where am I at here? YouTube launch. Here we are. Link to IoT. I think this is where it's at. AtomBeam. I don't know what that is. Sorry, guys. I'm just looking for it. I may have to just speakers. Yes, this looks right. Is there more? Is that just the only thing? That is what kind of file is it? Just looking for the files. Keynote presentation. I think this is it. So I'm going to choose it. I'm going to see if it's in there. It is a keynote. That's good. That's looking good. Okay, that's it. Okay, then I'm going to go through the slides. So let me see here. Okay, oops, I just killed it. It's okay. I know how to do it. I just did it. Okay.
Oh, we can't see what you're doing.
Yeah,
Right.
it's there. And so I'm going to just send it to Steve. Steve, it's coming your way. Okay. Oh gosh, this is better to do it now than when everybody's online. Okay. Time is it?
So what did you send me?
Just I got an introduction, so I'm going to share my screen.
Okay.
I'm going to just share the whole thing, the whole screen, because I don't even want to play around with anything right now. That's not the right screen. That's not the right. Okay, well, let's go get it. I think I just sent it to you, but let me go get it again.
Via email, text, chat.
Email. You can see, oh, today, that's you guys, IoT Meetup, yep, I just sent it to you. Picture, Shannon. Is this all in order? I wonder if I can just do date modified. Okay.
Since you have a Mac, it's super easy to trim it. You just open it in QuickTime, and you go to edit, and then trim, and then a little yellow thing shows up. You grab one end, you bring it to where you start, and then bring the other end to where you end, and then you're done. Then you just say save, just so you know.
You know what? I'm going to write that down. I'm not going to try to play with it right now because I'm going to go with the slides I have. They're what I would call published. Because if I try to do anything now, it usually turns out bad. I'm going to just show you guys the slides. Okay, I'm going to put it in presentation mode. I think I can just
Okay.
Can you guys see it okay?
Mhm.
Okay. And then I'm going to have to go watch the chat and see if I can put the chat over there. I don't know if I can. Let me see, what's this? Because I need to watch and let people in. Anybody see the people?
No,
Nope.
that's the thing. We have no line of sight to the people.
Okay, let's.
Okay, I see chat. So I'll be monitoring the chat, Charles, for you. And
Okay,
as
thank you.
questions roll in, I will.
Just interrupt me.
Okay, that works.
Steve, we might have two chats because it's also in LinkedIn. So it might be
nice.
okay. It's okay. If I have to stay here, I will, and I'll miss dinner, and my family will still love me. So let's probably.
Mine wouldn't.
I'm gonna have to share my other screen. Steve, let's do this. Do you know Apple pretty well? I'm still learning.
No, I don't know. I'm Windows.
Let me just stop sharing. It's okay. I can share it. Hold on just a second. Escape. There we go. And now I got my presentation. I can't see you guys, but that's okay. I'm going to just a second. I'm going to bring this. There we go. There you guys are. Okay. We only have 3 participants. We still have time. Okay, I'm going to share a screen and I'm going to share the other screen. The reason is then I can see this. I have another screen over here. And by the way, Apple works wonderful. This other computer, which I'm not going to show you because it has a brand name on it, I'm very frustrated with, but my Apple works great. And I'm not going to say the brand name. I'm not going to, it hurts somebody's feelings. So. Serious.
If it's Dell, get rid of it.
I don't own a computer
it's my work computer.
Yeah.
Okay, here we go. What can you see?
Your
an island.
Yeah, Catalina Island.
Good. Now I'm going to put this in play mode. How's it look?
Perfect.
Wait, okay. So let me go up to the front. I still can't see the other screen, so I'm not sure how to do that. So Steve, you may have to present, or Charles, send it to Charles and he can present. He knows apples. But this is how I'd like to start off, is just that, hey, my name's Shannon Duvendak. I am the head of manufacturing for T-Mobile. I actually want to put head of technology, manufacturing technology for T-Mobile. It's a fairly new position for me. And I also lead the IoT Meetup. And you can see that we actually had an event with a 5G, talking about the largest 5G network really within the US and actually the world. And so 5G, everybody's asking for more 5G in manufacturing. But today, I'm not going to be leading the IoT Meetup. I'm actually on vacation, and I have a very qualified colleague that I worked with before and also has presented here at the IoT Meetup. And so I'm going to turn it over to Steve Pierce, who's the Chief Innovation Officer for FBR, if you'd like to present or just introduce yourself.
Sure, I'm Steve Pierce, but I'm not the reason you're here. you're here to be introduced to Charles Yeoman, CEO of AtomBeam Technology.
Very good.
Nano.
Okay, and I'm trying to go to the next slide. Let me make sure I didn't mess something up. And ooh, somebody's asking to come in. Marcus Washington. Anybody know him?
No,
Looks
I
like a
don't.
football player.
Yeah, I know Marcus Nempacino, but not Washington. Charles, I sent you that the presentation that Shannon just sent me.
Oh, okay.
So let me
So
just.
you want me to run the presentation that you just sent?
You know, if you want to, Charles, you can. It probably would be safer if you did, and then I won't even present. I'll just watch your screen. But let me, I'm not going to let Marcus in yet. I can see him there. I want to come back here, and I just want to run through the slides. Okay, so this is how it is. I'll introduce. I'm not very good at it, and I'll probably screw up, but, you know, I'll say something. And it really is like a cool, they do have the best 5G. Seriously, I probed them. I've looked and worked with the
Wait, being a commercial, okay?
They really are. They are the best 5G.
Okay, I'm Verizon, but that's okay.
I'm telling you, I don't know. They got the godfather of 5G that works for them. You just
Okay, well.
Okay, so it goes here. I just want to say a little bit about what is IoT Meetup. It's really about, you know, about technology enthusiasts and innovative thinkers. They're all getting together. We really want to knowledge share on how technology can solve customer problems, really, I mean, make a difference in the world. And it's really to network and make friends. Those aren't the right icons because it's still a work in progress and I have dinner to go to, but that over there are real meetups with real people and real companies. And it's fun because it's not where we have to be all practiced up. We can actually talk. Here are the meeting logistics. Post your questions in the chat. And I would ask maybe if we could watch the chat, Steve, maybe we could have you watching one chat and Charles watching the other, or both. There's chats in both, or just Steve, you just watch the chats. And Charles, I don't know.
I'm watching this through Zoom. I'm not watching it through LinkedIn. So
I think you can do both. I started this one through the LinkedIn. So maybe you drop off and start. I think it's the same thing. Just go to the LinkedIn page. We'll try it. Anyway, I'll keep going and you can maybe play with that for a little bit. Charles, you're going to be focusing on just showing the presentation.
Yeah,
so,
yeah. It'd be good for me not to watch chat if I can avoid it.
Don't watch chat. You're going to just watch the screens and we'll,
right.
Even I will not go to dinner if we're not ready. Okay.
I've got it teed up, the deck that you sent on Keynote. And so, you know, that's good to go. And it's just a question of, you know, I'll do that. And then I can flip over to mine, which is in PowerPoint. And I'll just share a screen rather than sharing individual, you know, screen.
Perfect. And we are still 5:20, so we're okay. I'm going to talk just about the meeting logistics. It's real easy, you know, post your questions and so forth. I am going to talk about this. This is a little bit different. And it is because we are starting to get, and this has evolved, right? We're starting to get some really cool companies coming in like you, Charles. And so I want to talk first, having worked at Caterpillar for 25 years, you always start with a safety briefing, and I don't think there's a better time to do it than now. So just, you know, CDC, guys, if you haven't had your COVID vaccine, please do. If you work and you're like, well, I really don't care if I get a COVID vaccine, you're probably gonna, as everything starts up, factories especially, and probably all kinds of companies are gonna say, you can't come into my business, and it's gonna slow you down from that perspective. So pay attention to it, know what your company's policies are, and you know how it's gonna affect your job. Intellectual property, please protect intellectual property at all times and respect the company's brands. I mean, brands are they mean something, and they mean something to companies and people. Here is just what we had last month. We actually had at the IoT Meetup data platforms with HCL. Very cool presentation. It talked about ecosystems and customers and customers, and also suppliers and tier X suppliers. So the whole supply chain discussion was here with HCL. and hearing along with a panel of very talented professionals presented. This, I'm gonna start recording just so we get, oh shoot, I started it. Don't do that. It might start if we're not careful. Just pass through that. You don't want to watch that.
Okay.
And so here is, I'm gonna, Charles Yeoman is gonna be, can you pronounce your last name?
Yeomans.
Yeomans is gonna be presenting today, AtomBeam. And I'm gonna let him introduce himself, but before we do that, I'll come back. Hopefully you have a slide to introduce yourself. If not, come back to this one. I just wanna promote LiveWorks. Very, very, very cool. And I'll talk a little bit about that. We have some folks from PTC that will be joining. And I think they're inviting their customers. They also want the recording of it. But this was cool. This was better than the Super Bowl. I watched the commercials. Here is just a discussion about what's coming up next week. This is going to be a meeting on May 4th with NTS Innovations Whiskey Talks. We're just starting the outline, trying to pull all the information together and get the speakers finalized. Some more on this, and be watching for posts on what's DL again? Do you know, Steve? DL?
Yeah, DL from
Distilled.
Oh, Distillery Labs.
Distillery Labs. This is NTS Innovations Whiskey Talks Distillery Labs next week, May 4th. This is the last one. I'm not going to even talk about it, just different people. That's it. So you guys tell me when you want to start. I can cut any of these slides out if you don't want them. Charles, you have the ball and you'll control the slides. I'm going to stop sharing.
Okay.
Okay, and you're going to be the pacemaker. If you want me to introduce I would like to introduce the Iot Peoria Meetup and the purpose of it, because that's our, right?
So you're going to kick it off, and
Yeah.
I'll run those slides for you.
Yes.
And then after you've handed off to Steve, you're going to go get your dinner.
Maybe,
And,
if everybody.
maybe.
I've
And,
got the
and
chat, so.
then I'll just, do my thing.
All right.
Okay.
Steve and I
So-
work the chats, if we can.
Right. So you have 10 slides, and we're going to go through all of them.
You set the pace, because you are my pace keeper. Okay, so let's make sure the most important thing is you have time. If you have to skip any of those slides, skip them.
No, we'll be okay.
Okay.
Yep. I mean, I can do this in 3 minutes and 5 seconds.
Yeah.
So, because I have.
Shannon, don't wax eloquently on every slide. Get to the point.
Oh, I can spend like a whole hour in one.
I know.
That's right. Well, so could I, but
Yeah.
it just depends on how much, how big your bag is, right?
Yeah.
Well, it depends too who you're talking to. If they understand, like, I'll give you an example, digital thread. If you understand what a digital, we've got people ready to come in. I don't want to miss them.
Yeah, why don't we just start inviting them in? And
Okay, I'm gonna admit.
I think we're good. Charles, you're
Good to
setting
go.
the pace. I'm
Okay.
watching the chat. I went through LinkedIn. So I think we're good to go.
Okay,
Good.
sounds good.
I'm watching the chat. I'm gonna just, as I know people, and let them in. John Ringham is a retired cat. I believe he was I can't remember if he was a master black belt or a black belt, I don't know, but this is definitely a group I think would love to be connected with. Not only the IoT meetup, but also the Innovation and Startup Lab and all the work that Andrew Nui is doing with the city as well, because it's very cool. But I don't know. Hi, John.
Oh,
You're unmuted. You can talk. John?
Maybe you just went and got a cup of
he
coffee.
probably went to get a cup of coffee or something.
He probably did. He's been in one of these meetings before and he loves it.
Right,
or
more like
not.
a glass of wine, probably this time of day. Right.
Well, normally they're in person and we're drinking beer.
Oh, yeah,
Yeah,
that would be
so
good.
Yeah.
I couldn't bring it on campus, so I've got coffee instead.
Are you on campus?
Yeah, I've got much better internet here.
Really? Oh, I could fix that for you.
Right.
I mean, really cool 5G. I mean, and the thing that's really cool about it, since, you know, we can probably cut this out, but I'll tell you the real scoop. It is the best 5G. I do have it recorded but it was early and we only had like 2 weeks to try to prepare. Nobody really showed up, but you can, it's got 5G that's contiguous. It's different than any of the other 5Gs. You can go inside and outside. It can follow you into very remote locations. It can follow you around the world. And if they haven't, like, you have a problem and you don't have connectivity, they could probably, I'm pretty sure it's like any engineering group, right? They'll fix it. They're like, well, kind of cock their head sideways and go, I think I can fix that, right? You know, they're very capable, and they have one heck of a customer care group that's been outside, very focused on an individual, that is now focused on businesses that they've also brought inside to focus on their people, not just their customers, but their people. So it's a very cool company. Just saying.
Yeah, that's what I use.
Do you see? You're smart. Have you tried it? Have you done speed tests? I got more people to let in.
Yeah, I have. Right. And the
now?
FCC thing too, you know, the FCC is trying to
Oh,
get data.
hey, we just got an expert on T-Mobile who just joined, Tony Kerrigan, and he truly is an expert. Hey, Tony, welcome. These are my friends, Steve Pierce and Charles Yeomans.
Steve.
Hey,
Tony Kerrigan. Nice to meet
Hey,
you.
Tony.
And John Ringham, he is actually a retired Caterpillar. And I know he did some black belt work, and I just can't remember if he was a master black belt or I can't remember. So, but we got more people coming. Welcome, welcome. I was just bragging on you, Tony, and also bragging on T-Mobile. We got 1 minute, so I'm going to focus on letting people in. I'll continue doing that. Okay.
The other thing, put people on mute because I have no way to mute all.
Mute off. I got mute off. Mute off. How's that? Unmute yourself if you want to talk. Welcome, guys. We're getting started here. Actually, it usually takes just a couple of minutes to let everybody start joining. This should be coming in from the LinkedIn event as well as from the Meetup event. There's about 100 people that have joined the Meetup from the LinkedIn event, which I'm very excited about. But, you know, pull-through's not always 100%, but that's okay. We can still talk to the chat. The chat will be open for a period of time. I wish I knew the exact time. I haven't had a chance to really research the detail. So, but I will. It just hasn't come to the top of the priority list yet, mainly because customers are my top priority. So feel free at this point, if somebody wants to come off mute and tell me, did you join this meeting through the LinkedIn event? Anybody? I just want to make sure.
Shannon, it's Dago. Yes, I did join from the Zoom Zoom link that you have there.
Hey guys, that's another friend of mine, Dago Goncalves. Calvis, if I'm doing that right. Oh, we got lots of people coming now. We also have Keith on. All right, I'm going to keep admitting people.
You keep admitting them, and then we'll let Charles start it up.
Okay. Hey, Steve, if you didn't know, I'm going to actually, it's kind of a good time to even just do a little bit of chatting. And let me ask just a quick question. If Charles, you would feel comfortable, Steve, if you would feel comfortable, maybe hanging around a little bit at the end, because some people are like, hey, I have an hour. I did make this meeting maybe an hour and a half, 2 hours, I can't remember, like 2 hours, I think I did. But just stay on and talk and answer people's questions would be great.
Sure.
Wayne Coram is also on. He is also a T-Mobile employee as well as Dago Goncalves. He actually joined T-Mobile along with me to work with the Rock'n'Star 5G. And we work in manufacturing together. I like to say that I have the bias for technology. I do. He does too. And he's somebody that I actually go to on how to work like, I don't know, like Zoom and how to work all the different applications because he's really good at doing his homework on it. So probably knows everything you ever needed to know about LinkedIn. So, and he was my customer at Caterpillar. So he did all the critical customer requirements. He did all the go-to-market, working with the dealers. Steve understands this as you are the engineer, right? Work the engineering side. Dago, if you don't know Steve, Steve has, how many patents do you have out of Caterpillar?
A few.
Oh, come on. 100 and how many? Oh, come on.
I know Steve. There's more chance that Steve doesn't remember me than I do remember Steve.
Yeah. Okay. Why don't we just get this? It's all about Charles on this one.
I'm sorry, Charles. Are we ready? You guys can start. Charles has complete control of the deck. I can continue to let people in.
Yeah.
I have everybody coming in LinkedIn or on the meetup. So it's one. I'm continuing. Terry and Daniel are coming in. Ryan McCoy is coming on. Excellent. Okay, so Charles, you welcome. This is why we're all here, is for Charles Yeomans. And so Charles, you have the deck for today. So I'm gonna let you be our pacemaker, okay? And I can tend to talk too much. So don't fear about moving me forward. It won't hurt my feelings, so.
Okay.
We see, all right, perfect. I'll watch and let people in as well. I'm multitasking here. So welcome everybody. We do have over 100 people on LinkedIn that did accept the invitation. It means they're interested. Let me go ahead and introduce myself. If you don't know me, my name is Shannon Duvendak, and I do lead the Iot Peoria Meetup here in the Central Illinois area. My title is head of manufacturing T-Mobile. I actually am in negotiations with my boss to see if I can put technology on there because I'm a technology enthusiast. I will say though, we had T-Mobile join and join the meetup and actually give a presentation on 5G. It was fantastic. They did a great job. Unfortunately, it was kind of rushed. And so I'd almost want to redo on that. And I do have the recording of it. It's just uncut. So I prefer to really, I guess, polish it a little bit before. You want to go to the next slide? Okay, Mr. Steve Pierce is here to back me up. He's my friend. I've worked with him at Caterpillar, Chief Innovation Officer of FBR. And he also has spoken at the Iot Meetup. He is here to back me up because I am on vacation. And I'm supposed to go have dinner with my family. My family will forgive me because they love me. If I can't, for some reason, let people in or the chat, see both chats. So we'll work on that. Next slide. A little bit about the Iot Peoria Meetup. This was actually started by Terry Lewis, who is online with her husband, Daniel. These are real meetups that happen. You can see my friend Brian over here. He is from, I want to say the name of it, but I can't, it's too small. It starts with an N and the Taurus, but I can't, that's not even the right one. Anyway, Capgemini is also presented. They actually were talking about mobility and transportation in their presentation. And then again, several different companies who came in and actually presented. This is actually WePro up here. So it's a group of technology enthusiasts and innovative thinkers. This is not to be a formalized presentation. It is one in which things are not perfect. You can even see it here on the slide. This is a work in progress that I was working on and ran out of time before we got here. So I don't have all my icons where I'd like. This is about knowledge sharing, how tech can solve customer problems. Very, very focused on the customer, laser focused. And it's about networking and making friends. So this is just making connections. Let's talk about technology. Feel free to put things in the chat. It's not a formal meeting at all. We have 2 chats that are going on right now here in the meetup and then also out on LinkedIn. So Charles is in control of the slides and we'll keep the pace. Thank you. Just a little bit about the meeting logistics. Please post any questions that you have in the chat. I'd also like to ask people to please leave your email and addresses and make friends and connect with each other on LinkedIn. Please stay connected. This is about making positive connections, and you just never know. The people that I've connected to and talked to because of the IoT Peoria Meetup is exciting, and I really, I know I can feel it, I can see it by all the different companies and the people that come into the IoT Peoria Meetup and those that go into the Caterpillar Coffee Talks. This is starting to become a technology hub, and it has to do with some different companies like Caterpillar, Rivian. We have State Farm here. They're all starting to collaborate, and it's starting to take off. This is being recorded. I want y'all to know that. Next slide, please. Because I had 25-year career at Caterpillar, there's a few things that just really are important to me, and I really understand the importance of it. First is safety. I can't think of a more important time right now to be safe. And specifically thinking about COVID and the CDC and safety first. If you have not gotten your vaccine, I want to encourage you, especially if you're in a business, to do so, because businesses are going to, they're going to require it. They're going to have policies. They're going to not let you in and work with them. So just think it. I know everybody has their own beliefs, and that you're absolutely, welcome to your own beliefs, absolutely. But just think about that from effectivity and work and safety. Next one is intellectual property. Please protect all IP. This is important. A matter of fact, between Steve and I, Steve has, I forget how many 100 and some patents. We'll probably, we'll screen presenters that are coming in, and if IP sounds like it's being discussed, we'll probably mute your phone nicely. And then finally, please respect the company's brands. Next slide. I just want to talk a little bit about who we had last week. This was an exciting presentation. I did present it, or not present it, I recorded it. It's uncut at this point. I need to have a little bit more time to work on that, but it was very interesting. This is where HCL came in. Hiren was the lead from that company, talking about data platforms, but more importantly, not just data platforms, but the ecosystems. The whole ecosystems and how the thought of that is really going to accelerate really the pace of being able to move quickly, not only in the technology of computers and data, but also in taking machines and information and knowledge and solving customers' problems is going to start going like this. Actually, because of COVID, I've seen this in several presentations. COVID has caused the adoption of IoT to seriously be advanced more than 10 years. And I think it's accelerating more than that. There's some trends that are going on. I'm seeing trends in acceleration. I'm seeing trends in going nano. I'm seeing trends in data and neural nets going onto chips, trends in which things are happening in the automotive, but really in aerospace. I mean, go watch, and you can watch this in Tesla's investor days. So again, let's go ahead and go to the next slide in advance.
All right.
Yeah, this is a cool one. Do you like that?
Yeah.
So I'm the one that's actually leading the IoT Peoria Meetup. Then we got Steve Pierce, who is the Chief Innovation Officer. He's running it, and we're all here for Charles. Charles, you're going to be the center and focus, and we want to listen very closely. But also I wanted to introduce you to Andrew Newey. I don't know if he's on. I know he had some issues with having to pull his own COVID execution plan and safety. He is the Director of Innovation and Startups in the Greater Peoria Economic Development part of the Greater Peoria Economic Development Council, and is also going to be tied in with our group. One more, if you're okay. I do want to promote LiveWorks. Guys, that is the link. Please go out there and do it. This is better than the Super Bowl. No kidding. It's like you're watching the IoT discussion that's happening with LiveWorks, and that's very, very cool. And they have companies like Ansys, Capgemini, HCL, Infosys, of course, PTC, and Rockwell, and they're talking about how they're using the CAD files and the digital twin and the digital thread in the applications of efficiencies, not only in the manufacturing, but also as the products go out into the field and out into the wild. And then there's even, I believe, a supply chain discussion in there, because I heard all about that in the HCL discussion. So just know, if you go in, you sign up, you register for that. They are doing this really cool. It's in 1 hour chunks. I've watched one of them, episode 2 just rocked. I think that's the only one I watched, but I want to watch all of them, and I want to watch it again, and it's better than the Super Bowl when you watch commercials. It's great.
Well, I'm pretty sure next year you're going to see AtomBeam on that, because their technology will really enhance what PTC does. So
I can't wait to see it. It better be on a chip. I'm hoping it's on a chip. I think it is. I think it's nano. I'm seeing all kinds of stuff go to chips. So next slide. Okay, this is it. Next week, May 4th. If you have not seen it, it'll be Andrew Newley who is posting it. I'll be posting it soon. This is like next week. But this is NT Innovation Whiskey Talks, and it is very cool. It talks about actually chips, and it's going from silicon to another type. I think it was
graphene energy harvesting.
Thank you.
And Ryan McCoy's on right now. Another amazing technology. And Charles and Ryan should be getting together after this talk as well. So
there you go, Steve. We're connecting the dots. It's all about startups. It's all about connecting dots. All right, cool. I think I'm done talking. I'm going to watch the chat. Please, you guys, if you haven't, you probably want to go past that. That's definitely not done yet.
All right. Okay.
Okay, it's all yours, Charles. Rock and roll.
All right. Here we go. All right. Well, I really appreciate the opportunity to talk to this group. Thank you very much for inviting me. And I think there is an awful lot of connections here that, we could very well be applicable to. So I'm Charles Yeomans. I'm CEO of AtomBeam. And I'm really more of an MBA type guy than a technology type guy, but I've spent enough time in technology to be at least a little dangerous. So what AtomBeam is about is it's a software, but it can do the same thing that building out hardware infrastructure to quadruple bandwidth, but entirely with software. So I'll explain how that works, but it's a pretty radical rethink of how you would reduce the size of these small machine generated files that really can't be done any other way. So I'll tell you about how we do that. So what we're addressing is something I think everybody on this call is pretty familiar with, which is there's an awful lot of IoT data now, and there's going to be an awful lot more not too long from now. And to give you a sense of scale, so getting to 90 zettabytes of IoT data generated in 2025, the total capacity, storage capacity of all the data centers in the world combined is not 2 zettabytes. And so this is a really big number. And the other thing to know about it is, and this is based on different articles, but it's also based on Palo Alto Network's observation of IoT data, which they watch going by to see how much of it is encrypted. 98% of it isn't encrypted. And the issue is most of it or all of it should be at least somewhat protected. And so but the issue is, do I really want to spend the money on a really high-end encryption, which is necessary for many things, but not for how cold your refrigerator is or some things like that. So this is what we do to address both those things. So we're using what is in effect a really old idea, which is the idea of a code book, which is essentially matching up keys and values. But we're applying some, really modern techniques. That is machine learning. There's some pretty exotic math. This is really driven by mathematicians. And by doing that, making that combination work, we achieve some pretty dramatic results. It's really, it takes you right down to the bit level, which means that we could apply to essentially any data that has patterns in it. I'll explain how it works. So I think probably most people here know how compression works. It operates on one file, looking for repeats of patterns. And most people would tell you that it doesn't work for IoT data because IoT data files are just too small to have repetitions of patterns. And so it really isn't useful unless you're taking a whole lot of these files, packing them together, and taking the latency that is involved in that. And so what we do instead is we address that issue of being able to find these patterns. So we look at thousands of these little files at once, and we're looking across them using machine learning to find repetitions of pattern. When we find a pattern that gets repeated a lot, then we put it into a code book and we assign a code word to it. Once we have found a bunch of patterns and assigned these code words, which are really just indices, then we take this completed code book and we can put it into a source, like whatever, like a sensor or a gateway or something, and then also into the destination, which could be a server, it could be a phone, it could be anything. The heavy lift computationally is up here in generating the code books. This is really straightforward. It's just a lookup. And so really what we've done is create a dictionary whereby these patterns are identified by these small indicators, these small code words, so that when a file is generated over here, it gets sliced up into whatever the pattern length is, translated into code words, just in a lookup, and flipped over to wherever the destination is. And then the reverse happens. That is, you can take the code words you receive and restore it back to the original data. It's 100% lossless. We've literally never lost a single bit. And so it works really well. Couple more things to mention. The theoretical limit, we haven't hit it yet, of the speed here is 400 times faster than the fastest compression. And so really you're saying, okay, if I can cut the amount of data by 75%, I'm really quadrupling the bandwidth because the computational latency is so small. The other thing to mention is the AtomBeam dynamic, which is if the data changes over time, this can generate a new code book and provision it back over here. And so, the idea is to be able to handle anything in the end of the day, so long as there are patterns. Any questions you want to bring in, Steve, or at this stage?
None yet, but that's really amazing. So it learns real time on all the new data coming in to create more codes to further improve the compaction.
Yeah, right. So and it'll either further improve it, or say you're getting 75% here reduction, and then it might say, and then suddenly it deteriorates to 60% or something, or 70%, whatever your parameter was. And then you say, oh, it's time for a new code book. It generates a new code book, puts it over here. Or, as you said, it could improve over time. It's machine learning, right? And so you can build better code books as you go along. And so that 75 could turn into 80, but go ahead. Sorry, Shannon.
Oh, I just wondered, just curious, are you using like neural networks that are on it or just a generic, different algorithms of AI?
No, it's not. That's not the magic. The magic is in these sort of exotic math, the exotic math piece. Yeah, it's not neural net.
Okay. I know there's many different ways of doing it, right?
Yeah, right.
Yeah.
So this is what really happens when you do this. We generally see, on average, a 75% reduction. Sometimes it's gets as low as 60, even 50. Sometimes it's well in the 90s. It just depends. But on average, over a lot of different IoT type data, we generally see a 75% reduction. And again, that's a quadrupling of the bandwidth in effect.
So I got a question in this. So it's just easier to ask it as you go. Again, I gotta try to connect with my family. So I'm really curious, right? So, if you're working for a customer, I'm gonna really focus on the customer, and at Caterpillar, we had telematic devices all over the world, right? And it's all about getting that data, and I really think about it, as it's inside the factory. You got your E-bomb, you got your M-bomb. So do you know what a manufacturing bill of materials? And it's okay if you don't.
Yeah. I mean, I have a general idea.
Okay. It's just engineering is basically you have all the options. It's called an E-bomb. Manufacturing, it's what kind of information do you need to go through the factory, and which lines are you going to? What material are you consuming on the line? What kind of signals do you have to send your suppliers? So that's the M-bomb, and then you got the S-bomb, is how you service it. And so if you think about your cut, at least from a Caterpillar perspective, and I'll speak specifically to, it could be engines, or it could be, construction equipment, or it could be mining equipment, whatever, goes out all over the world in all these different applications. And so you're sitting there compressing things, but it's about that data that's going, right? It's that thread that's going along. Mm-hmm. And I'm just wondering if, my friend keeps getting dropped. I'm gonna let him back in. Okay. Sorry, guys. I'm talking and letting people in at the same time, but I'll let them back in. So here you are. You're trying to do this data, and it's on this. It's got that digital twin that goes out there with it, and that's really just the CAD file because it's got the three-dimensional characteristics of it. And then you have the data that travels with it, and then you need a network, right? So that's the thing with this rockin' 5G that comes out of T-Mobile, and I'm serious. I always think of for the customer as this
commercializing.
Yeah, I told you, right? I did. I worked with
Okay.
Come on, I did it with you, great engineers, and I want to put not only N in it, or not.
Keep talking, Shannon. Keep talking.
I know, right? Not only the D, right, for digital, now I want to have the M for mobility. Come on, let's do the total cost of ownership for our customers. Focus on them. So I'm sorry. So my question is to you. So how do you fit in that ecosystem? So you're compressing things, think of total cost of ownership, right? Mm-hmm. And so that customer, right, they're going to pay, they want everything for free, right? Well, I do too. Mm-hmm. I want everything for free. And but that's a negotiation, art and purchasing. So, we all want to do the best we can for our customer, but it all costs everybody money to do this. And everybody needs to make a living, and everybody needs to be paid fairly, and we don't give stuff away for free, right? Because we have to make money. So help me with that part of it.
Okay. I think I do address that kind of more as we kind of go along, and I don't want to not address what you're saying at the moment, but I think it flows better if I.
Please flow it. You're in charge.
All right. Very kind. Thanks. So just there's a few other things that come along with it that are just part of the basic architecture that is AtomBeam's technology. So one of the things is this light security. So we're sending, instead of sending the original data or representations of actual things in the world, like the letter E or the number 2, we're sending representations of patterns. And therefore, the data, when you get a code word, is not readable without a code book. And consequently, you are getting getting a kind of encryption. And it's not post-quantum super duper encryption, but for the temperature of your refrigerator or the moisture level of your cornfield, it's really all that most people need for most things. And there's other things we can do, but that's the key thing to understand. And then another thing is batteries. So an awful lot of IoT is driven by batteries. And if a battery is the biggest use of battery, rather, is typically the sending of the data. And if we can dramatically reduce the amount of data that's being sent, then we can also usually extend the life. So it varies all over the place. And if little tiny bips of data isn't going to use much power, but a typical IoT device is going to send something. And so generally speaking, 50% is more time is what most sensor guys have told us that they would reasonably expect. Another thing that's cool is random access. So if you store data in a data center, it's compressed and it's usually deduped. And once you do all that, then you can't do anything with it until you take it back out again to be used, to be looked at. Ours, you would send it to the data center and just store it in the code words that it arrives in. And you can use those code words, you can leave it just stored like that, and then you can access it as though it was the original data. Now, we haven't released this yet, but it is in prototype now. So you would be able to type in search terms, randomly access files or parts of files, just as though they were in the original form. But you're getting the advantage of the significantly smaller due to that you have to store it. Another thing is cloud storage. So if you're sending your data to AWS or Azure or whatever, it's arriving 25% of the original size, typically. And so that translates, they can't charge you for storing data that they didn't get. And so if you get 75% reduced size, then you're going to pay 75% less for your storage. And final thing that's sort of the extra benefit here is the range. So if you have a constrained bandwidth and you free up 75% of it, then you can use that other 75% for additional error correction. The theoretical, the equation of this says that 75% you will double the range. However, of course, real world you get something less, but significantly longer is a reasonable statement. Any questions on this before we move on? Okay. So I have a couple of few examples here that I thought I'd talk about. One is the first one is this truck fleet. So there's a truck fleet that has that operates in West Texas. They're out of cellular range a lot. They wanted some way of rerouting their trucks to pick up loads, even though they're out of cellular range. And so they talked to a telematics provider, and the telematics provider suggested satellite. But the quote for the cost of it was just too much. And so what the telematics guys worked with us. We reduced the size of their datagrams by 93%, but you can only reduce it down to one packet, and so that means that we save 2/3 of the cost. But it's still pretty good, and those are on trucks right now being tested and so forth. So I don't know if they'll do it because they still don't want to spend any money, of course, but they do. It does work as advertised. So here's another one. This is sort of interesting. So there's a company that has that deploys ag sensors. They, it's like all sorts of stuff in the cornfield and the storage thing. I can't really the what do you call those things? The tall things with a bill, whatever. So they have all these things that monitor all these things in farms. They send not much data, very little, but they spend $1.20 per month per device. They aren't sure exactly how much they can reduce it, but they think if we can reduce the amount of data they're sending by the amount we've tested, they believe they'll be able to cut the price, they think, at least to $9 and maybe less per device per year. So another thing is, so we're working with this electric bus maker. They send a boatload of telematics, like 600 megabytes an hour. But they are using compression on most of it because they don't want to pay the extra cost of sending all that data. And so we can translate that, all of that data into real time. And they would probably, they believe, and they're being a little cagey about this, but we believe that they're going to save around 20% compared to what they're paying now, and they go to fully real time. And so it's, in that to them is a huge benefit. I mean, this isn't driven by the cost in this case. This is driven by the fact that, they really want real time. The other thing is they think on the back end in terms of storage, they will save money as well based on the, reduction they've been seeing. So this is sort of a little off, but I thought I'd mention it. Steve thought it would be useful for me too. So one of the things that is a big deal is this having searchable, randomly accessible stored data. If you're talking genomes, which are about 60 gig each, and you have, say, millions of them in storage, to do a little work on them, to look for a sequence across, dozens, hundreds, thousands of these genomes, you are really having to deal with a lot of decompression and dedupe. It's a very extended process. In our case, all you need to do is take you type in your search terms, would be basically show me the sequence from this to that, and then oh, my dog, sorry.
That's great.
I was like, hold it off, because first it was the chickens, then it was the dog. So anyway, so the, where was I? Oh, so anyway, so the genetic research guys think this is going to be a really big deal because they can, type in some search terms and look at 1 million genomes all at once. So you can't believe how excited they are about it.
Well, and the reason why is I've got a friend who works at the St. Jude Hospital in Memphis, and they do a lot of this type of work. So I was pinging him, getting him in touch. The other thing too is if you could do this with genomes, why can't you do it with the data like Shannon was saying, as far as the BOMs and all the parametric information within PTC and so on. It just, to me, if you could take and, compact it 70%, it's kind of like a trash compactor. It's all there, you just got to, uncompress it. So that's why I thought it was very interesting. Plus, we've got some really big hospitals with innovation centers, the Jump Innovation Center here at in Peoria. So
Cool.
It's
good stuff.
Oh, there's no question that could, I mean, I've already had discussions with, I'm sorry, Roche Diagnostics. They actually came to us and wanted to know about this. And there's, Stanford is interested in it. There's, I was approached by a guy who does remote EEG, that's a company, it's actually a sizable company, they do remote EEGs. And it's, they want to know, well, let's work on our stuff. And we tested it, and sure enough, we do much better and than compression does, and we're real time, unlike the compression. That's a key thing to mention here and emphasize is, translating your data into real time from some sort of latency prone approach that uses compression, because you're waiting while you gather up enough that compression's effective. We really have a big time, advantage when you need that real time data. It really isn't the same thing at all.
I got a couple questions. I'm
Sure.
sorry, I can't help myself. I'm trying not to, but
Fire away.
curious. I got a really stupid question first. I'm sorry. What's a genome? Is it what
Oh,
is
a
it?
genome. That's just your DNA. It's a DNA strand. And
Oh, got it. Okay, cool.
they're
And-
just big.
okay.
Yeah. No
I
problem.
wasn't sure. I was like watching chats and letting people in, trying to look around. So, okay, great. Got it. Now I got a question.
Okay.
You're talking real time. Like, what's your latency? I had somebody, I was working on with a customer, and they were given some ridiculous number. And when I'm like, why would you ever need something that fast? And this was in a factory of all things. Like, why would, maybe it was out somewhere else in a while. I'm like, what latency do you need that's like ridiculously fast, and why?
Sometimes you do need it. I mean, the estimate is from IDC is that in 2025, 30% of all IoT data needs to be real time. And it's kind of like it depends on the use. I mean, for instance, say you had a robot and it was a remote control robot, and you wanted to have the robot do something or detect something. It detects some sort of fault. You don't want to like spend a lot of time thinking about it and what am I going to do and stuff. You want to react like now. That's one example. Or a crash sensor on the front of a car. You don't want to like think about, okay, what do I do and everything. You want to like do something now. So there's lots of circumstances in which, you want to know something's right now.
And and this was the thing that was really strange about that. I get it, right? So, you might have to do, and it's really from safety perspective, or you got somebody who's, I don't want somebody cutting me open and go, oops, I'm sorry, I accidentally took
Right.
your liver
Remote
out,
surgery. Right.
Right. But this was like a ridiculous speed, like it was trying to smash atoms together. It was ridiculous speed. I mean, is there anything here with these?
Well, think about it this way. Say I have data that I've reduced in size by 80%. That means that the data is going to get from A to B 5 times faster, net of any computational latency I'm adding, right? And speed of light. So that says, okay, what's your computational latency? And that's why I was emphasizing the 400 times faster than compression limit. Now, I'm not advertising we're there yet, but that's a question of optimization. And so we are fast. And if you think of the computational lag as being pretty close to zero, I mean, it's never going to be zero, right? You're always going to have something, but it's really small. And if you can reduce the amount of data by a factor of 5, and you aren't adding much computational latency, you have data moving close to 5 times faster.
So Charles, do you see this as a potential opportunity for AR and VR, where you have all these programs and a boatload of data that if you can compress it with the low latency on top of, how things, the 5G from T-Mobile that, makes my headset work perfectly, if they had less data, then it would, I think, improve the overall experience of both AR and VR.
It's important to note this, and I should have made it more clear before, have to have patterns. If you're talking compressed video, there's no patterns. I mean, they flushed out most of those patterns. And so with respect to the video piece, you know, we really can't do much of anything because we are focused on lossless, moving data losslessly. When you're talking about video, usually you're throwing out almost all of it to get down to the stuff that the human eye actually needs to look at. So that's one thing. Second thing is there's to the extent that there's other data that's moving, you're detecting your motion or whatever that, you know, other stuff is. Yeah, you know, we definitely can affect that.
Excellent. Okay, we'll let you continue. Sorry.
No worries. Okay, so just a couple of thoughts here on some of the applications here that could actually work and apply, and this is an instance. So telematics, you know, we're doing a lot of work in telematics now. And, you know, there's lots of stuff that we can make real time. Maybe we can reduce this cost of your data. Maybe we can reduce the cost of your storage. But an awful lot of it, the focus is, especially in big companies, it's not so much about negotiating a lower price for moving the data. It's more about sort of the high speed of the data in many cases. And it isn't even, and I'll deviate here a little from the slide because it's not only like from the telematics device, but sometimes it's actually on the machine moving data from A to B. And the more autonomous things are, the more that becomes an issue. There's, you know, there's a lot of interest. There's a big Korean company that is not only looking at it for telematics, they're the biggest supplier, I think, in telematics for autos, but they are looking at it for moving data around on autonomous vehicles because that is a big issue. And as all sorts of machines become more autonomous, it will become a bigger issue. It's really a robotics thing. So, and just to mention a few things in manufacturing. So digital twin, you have lots and lots of data, CAD data moving. And, you know, we haven't done a lot of work there or in robotics yet, but, you know, we can, you know, if it has patterns, it'll work. And it's fast. So another thing is the data center traffic. So we can move data around between servers really fast, even on a logic board between processors, even on a chip between buses. Now that's theoretical at this point, but we have a patent and we haven't chased it down yet, but that is something that could really happen. You could take our stuff, put it on a chip, and have, so long as it's processed, not processing video or something, put it on a chip and have it move from bus to bus faster. So that's out there. I don't want to go into something that's kind of on the theory side, but this is sort of a theory kind of thing, right? So anyway, so, you know, what our plan is here is we would get, we really want to be in devices when you buy them, you know, from a manufacturer, like whomever, like a Cradlepoint or, you know, Sierra Wireless or somebody. And they get a free client, they put it into their stack and it's there. We're also already integrated into AWS, Azure to a lesser extent, but we're going to work on that. And we want to be in all the cloud providers. So at the end of the day, you buy a box, it has AtomBeam in it. And if you want to use it, you check a box and it works. And then the bill, what we really want to do is have AWS, et cetera, just add in another service, just like their IoT service, just like number of messages, as whatever. If you're sending them in using our stuff, you would pay a small fee for that. And that's how it would get charged. I mean, right now we charge like on a basis of, you know, you would have X number of servers with our stuff and this many devices attached to those servers, et cetera. But this is where we really want to get to. And testing our stuff is really simple. If you want to try it out, you get a all you do is get a login, and you upload a data set. It goes to an AWS instance. We don't have access to it. And it generates 50 code books. We always have an 8-bit code book because 8 bits is small enough that we can have all 256 versions of the binary combinations of 8 bits. And so that means that if the variable length code book, because it generates 25 of those, can't find a match, because you can't have every combination, it's too many, it flips into the 8-bit. The 8-bit then can encode everything. So to get maximum efficiency, you want as many as possible encoded by the bigger, longer primary code book. Generally speaking, 90% plus can be done by the regular primary code book. Once you get that, it tells you that first one column there. Here's what your best compaction is, second best, third best, and finally, if you only use an 8-bit code book. And then you can download your code book, and you can also push it into a simulator, and that's the other screen over there, and it'll show you it in action and how much CPU you're using and blah, blah, blah. So all that kind of stuff. And so really in that process to do that, that's step one. It's like really a half-hour kind of deal. Just get the login, type in the stuff, and upload your data set and push a button and it comes back at you. And then if you said, well, this is great, I'd like to try it, well, you can just go and you can just ask us, and we can send you a couple of provisioned servers, and you can just put it in your lab, and it's cable in, cable out. You just test it and do whatever you want. And then that way, the week is just how long it takes us to ship you the boxes, right? It's not, anything else. And then you do whatever testing you want to do, and all that's free. And then if you said, okay, this looks great, I want to move to this, and then we'd go through a POC process, which varies obviously in length and depends on what we're integrating it into and how many different things and all those other variables. But at the end of the day, you'd want to field test however many units by just building it into whatever the stack is. Now, when we get a little further down the road, the great thing would be is that you just order something, it's already there. But at this stage, we need to build it in. So we're trying to make it as simple and easy and painless as possible to get to the point where you say, this is worth it. I'd like to take this next step. So just as a little reminder, there's lots of sort of benefits. So eliminating latency or greatly reducing latency is a big driver for many potential users. And cost savings, either through the data transmission or storage or whatever, it's people who batch, or that is say companies that batch often lose a bunch of data. And because some guy forgot to do it today or whatever. And so stuff gets screwed up. And, we also have the latency. Another thing is it's just competitive. People expect to have streaming data now. And if you're still batching, then it will increasingly be a competitive disadvantage. And finally, being able to randomly access your data for analysis and makes analysis way simpler. We do a lot of stuff that's pretty simple, straightforward, easy to do. Our focus has been, how do we make ourselves how do we make this as straightforward and simple as possible for anyone to test? And I should mention too, if you really want an SDK, we have an SDK, and you could just ask for the SDK and install it in your stuff. So, whatever suits you, we're happy to do. And you can just get a login and say, I just want to try it out. Don't want to talk to anybody. Don't want to do anything. Just want to try a login. So anyway, so that's really it. I mean, the rest of the stuff is, like what we like to do to help out. And, obviously we're trying to get customers, and we're being as accommodating as we possibly can be. And there's contact information for you right there if anybody would be interested.
Yeah, take a screenshot if you're interested. To me, this is really amazing because you're creating virtual hardware. You're increasing my infrastructure by, 50, 60, 70% if I just put it in on all my devices. You've literally just saved me a boatload of money. And the better the algorithm gets, the better, faster, cheaper it will become. What I'm going to do is because we have 7 minutes and then we'll stay on if anyone has questions to ask, but go ahead and unmute your mic and ask Charles questions if you have any.
Hey, Steve, if I can just make one comment, because my family really give me dirty looks now. I'm in big trouble. They still love me. So I'm just, honestly, the type of content that we have in our little IoT Peoria meetup, I can't imagine how this thing would explode if we had the backing of some, rock star companies, like T-Mobile or PTC or whoever, with their great marketing capabilities, and just add it, it had time to promote it and add it. And I think the total cost of ownership from sponsors would be pretty low. Just a thought, and then we could tie it to the Innovation Center, and then we could tie it to schools, and we could tie it to cities, and we could make a whole, actually, here's a great vision, right? This whole tech center corridor in central of the United States with some rockin' universities up in Chicago, really tying it to something that I learned from Terry Lewis, following her around, was something called P33. So I don't know. I think it could. I think the time's right. I think we got everybody helping each other and caring about their families. And you go into the grocery store. I'm seeing old people trying to use technology and young people trying to help them use the technology. So I think the time's right. And this is pretty cool technology.
Well, we worked at Caterpillar, and we know that to get a big corporation to move and to sign on the dotted line, even if you have the best technology ever, if you miss the budget cycle and so on, I think what would be kind of cool is we get some medium-sized companies and really put this into action.
That is like how we've really tried. Sorry to interrupt.
No, you go right ahead.
Okay.
I seriously do have to go. I'll say one last thing. If you watch investor days of lots and lots of companies I do it just because I enjoy it. And then I also do it, if I'm trying to make sure I understand a customer and kind of what they're going for. But there's lots of budget out there. There's lots and lots of budget out there. They're underinvested. I'm seeing the words in investor days, multiple companies underinvested in technology. They have budget. I think we just have to go get it. But
hey, Charles,
Yes.
This is Terry Lewis. This was very interesting. Can you expand a bit more on your commercial model and some of maybe some other use cases of where you've had people, successful?
Oh, sure. Yeah. So let's see. So I would say, what I talked about, I'm sorry, I'm gathering my thoughts here. What I talked about back here, I want to emphasize, where is it? Here is where we're headed. Right now, what we do is we say to a user like this electric bus company, okay, it's $15,000 per server per year, plus in that case, we're charging them $5 per bus per year. They're getting way, way more value than that out of it, but they're, you know, early customers. And so early customers get a deal. You know, that's successful happening, you know, I mean, they've raised like 700 million. They're going public next year. They got big profile of the Tesla electric buses and yada, yada. But they're able to use the technology themselves. They have the engineering capability, and all that stuff, as opposed to the big company, a $50 billion Korean company that is a leader in automotive telematics. They did their extensive testing. They signed off, yes, it works. They offered to be, you know, a reference. But what they've done is they built it into a prototype, or not a prototype, the architecture of a new telematics device that they want to sell to their customers, big, you know, automotive makers. They are in a much longer cycle because first they have to talk to them and say, here's why it's cool, and here's the other things about our telematics, and yada, yada. And so the point I'm trying to make is we have referenceable customers that are big, but we also have smaller customers that are moving forward now because we don't have to wait for them to decide. You know, they can decide for themselves and they can implement it themselves. There's another company that does DoD satellite connectivity, and they, I think, are going to be. I mean, they're not there yet, but they've done all the testing. They want to move forward, and we're just talking about some of the architecture stuff and all that. And I think they'll be, you know, in the house here in the next few weeks. So, and then
Charles, sorry, going back to your Korean telematics provider, is their value prop to their customers just reduced bandwidth versus what everybody else is selling to them from a hardware perspective?
Part of it's that. Part of it's that they want to be able to provide increased bandwidth, because as cars become more automated, they generate more data, and to the extent that they can expand the bandwidth without expanding the cost of sending the data, that is, say, expand the amount of data being sent without increasing the cost of the data being sent. That's a really big deal for them. And they see that as stage one. Stage two is they also have an interest in applying it to other things, particularly autonomous car internal connectivity stuff, because there's a giant amount of data that moves around in autonomous cars, not terabytes, you know, just terabytes an hour kind of stuff. And so, you know, but they have not done that yet, but they have proven to themselves in their lab, yes, this works and does what they say, and they got like 84% reduction. So, you know, and like I said, if somebody wanted to talk to them, I could talk to them.
Oh, thank you.
Sure.
Hi, Charles. This is Keith Gargiulo of the aforementioned PTC.
There you go.
Appreciate this. I actually only made part of the cat discussion that you had along these lines, so it was great to be able to hear the whole thing this time.
Oh, good.
I definitely want to get in touch. I've shared information about you from what I saw in the first round with our enterprise architects. I'm going to go have the same discussion with the head of our IoT business. For sure, we run into this. It'll be a really interesting discussion about assets versus other models, about some kind of, you know, if there was something embedded, because there's all sorts of complexities to think about and work through there to make it easy for the end user. Exactly. Or something embedded versus, you know, direct through you. I think those will be interesting discussions. I actually had the date wrong for this. I thought it was a month from now until today when Steve pinged me and said, "Hey, you going to be on tonight?" I said, "What do you mean?"
Right, right.
So
Good.
I have
Well,
them
I'm glad you
invited,
did. That's
I'm sure
great.
they didn't make it because it was very last minute for me to update them on the date, at least to me, the date change. But I'll be circling back with them, and I definitely hope to get back in touch with you.
Terrific. Well, you know, if you think about this whole thing, it's kind of, this is all your architecture, right? I mean,
It
you
is.
know, everything's soup to nuts except for the hardware, right? And if, you know, I haven't mentioned it here, but it is absolutely a, you know, something that's very doable. If you were integrated, if you had us integrated into what you were doing, then you were provisioning these devices, you were provisioning the cloud, you're, you know, doing the whole thing. It makes a lot of sense. We've thought about that being something that we should be talking to. And it's just, you know, we're a small company and you've got to pick your spots. But at the same time, if you have an interest, it's definitely something we would want to chase.
One of the things I do at PTC, and sometimes it's folks Steve finds for me, sometimes it's things I find on my own, is try to make connections like this. Sometimes it is hard to, within PTC, to get certain things raised above the noise level of what everybody's already going on. You know, that's a fact. I've had reasonable success in the past years of trying to make that happen. But I'm definitely I'm on this one because it definitely seems incredibly relevant to challenges that our customers face.
Cool, that's great.
That anyone is going to face in simply paying the bill for doing something at scale.
Yeah. The other really interesting thing, Charles, that you mentioned when you talked with Kat was the fact that if you take this code book and then encrypt it, the data is so removed that it's damn near impossible to go back and reconstruct it because your code words had nothing to do with what the data was to begin with.
Exactly. No, you got it. I mean,
it's like a Navajo code talker analogy.
Right. You've double encrypted is really what you've done. You've started out with the data. You've turned it into representations of patterns, which have nothing to do with anything in the real world. Then you've made those, you've encrypted those. So and if you want, you could do the shuffling thing, which is really code word A, pattern A, code word B, pattern B, etc. And everything just moves around every second if you want. So you can make it NSA, you know, challenge kind of stuff if you want. I mean, and I've talked to NSA people and they said, this is a really good thing for an awful lot of different sort of things. I mean, without adding encryption, just, you know, regular. If, you know, there's so many things that don't have any protection at all, but really should have something. So that's one thing. And then she also agreed, and she's a 30-year veteran of NSA. She said, yeah, you know, if you're obscuring the data before it's encrypted, it is a very challenging thing to address. And she didn't say if she could or not, but, you know,
it takes away a lot of the brute force approach. Yeah, you can't just throw more computational power at it and figure it out in half of the life of the universe instead of the whole life of the universe.
Right, exactly. Or you just get a quantum computer, right? So,
well, and things like medical data, the ability to move medical data, you know, HIPAA and all that, you know, you might have enough security just in your first, you know, code book to move medical information relatively freely over the phone and on and on.
Yeah, so that's what that EEG guy, that doctor says.
Okay.
One thing he's thinking about, right? Yeah, no, you're right. I mean, it's again, not post-quantum super duper encryption, but do I really want to spend $1 adding that to my moisture sensor in my soybean field, right? Yeah. I mean, which costs 50 cents. You know, so it's just, you know, because like most of the people, when you talk about, you know, security and encryption, you're mostly like, oh, ours is really, really good and everything. And it's like, but you really need really, really good for, you know, like, you know, your thermostat in your house. So You definitely want something. You don't want people messing with it, but you don't want it to, you don't need to go all that level most of the time.
Even though all the technologies are based on Moore's law, exponentially getting, every couple of years getting cheaper and so on, data storage, computational and all that, the amount of data we're creating is more than exponential. It's an accelerating exponential. So having a technology like this, even with Moore's law, even though it's going to get cheaper, because we're generating more and more data, our costs are going to rise. And this technology will bring it down such that over time, it should decrease the way you think it should because of Moore's law, rather than we're creating more data to fill the void. So very exciting stuff.
It's really cool when people get it. I mean, I appreciate that. I thank you for saying it, because not everybody gets it, but when the more technologically sophisticated you are, the more you understand the implications, and it's really cool. And I get a chance to talk to folks like you guys.
Well, excellent. Are there any more questions? I know I've monopolized the time. This is really great stuff. Are there any more questions? I'll shut up. Okay. I'll take that as Charles. Thank you so much.
My pleasure.
Once again, could you put your contact information up one more time?
Yep.
If you're interested, take a screenshot of it, copy it down, take a picture, whatever you'd like to do. But, feel free to reach out to them.
Please.
Any use cases you have, you make it so easy. So it's easy to experiment. Failure doesn't cost anything. It's a learning opportunity. You take a chunk of your data, you feed it in, and you see what happens. So really, really great stuff. Other than that, thank you. And hopefully somebody gets in touch with you from this area. And there's a few people I want to introduce you to a little bit later, and I'll make those connections.
Thank you. That's great. I appreciate that. And thank you everybody for showing up and listening in. It's really great when you have a chance to talk to people and tell them, be a little proselytizing. I agree, I admit, but I do get excited about this stuff. It's really cool. This could be how in the future, how just most machines talk to other machines. It could be.
Definitely agree. Have a great evening, everyone. Thank you for joining. Take care.
Great presentation.
Thank you very much. Appreciate that.
Yep, enjoyed it a lot. Thanks.
Yeah, thanks, John. And nice to meet you. And Steve and I will stick around if anybody wants to chat or ask questions or anything.
Yeah, the concept of building it in on a chip and making it ready to go, I think is so. And Ryan's Ryan unmute.
Hey, Charles, I'll come off mute.
Hey.
Hey,
how you doing? Great presentation. Really enjoyed it.
Thanks.
So that. Ryan has the graphene energy harvesting. So essentially, if you're above absolute zero, there's energy that can be harvested with graphene. And they're a startup, they're doing some great work in that. But I envision you two getting together, your companies getting together, and with the energy harvesting, with the compaction, the ability to reduce the size of any energy storage diminishes even more, which the value proposition then goes up dramatically. But, you know, could you in your foundry process put in a little AtomBeam circuit that could then take, you know, the energy and then communicate with the processor to reduce the total amount of energy on that device and build it in as a added feature? So way out there. I know you got to get the harvesting right first, but you know.
That's right. Yeah. So Charles, to fill in some color on what Steve is saying, we're developing a technology that was that originated at the University of Arkansas, and it's a nanoscale energy harvesting technology that we're packaging on a chip. So we're essentially creating a sort of a little wind farm on a chip is what I've referred to it as in the past. The difference between us and a wind farm is you need wind in the case of the wind farm. In our case, all the energy harvesting takes place at nanoscale, and it's packaged inside the chip. The really interesting physics
that is
makes
interesting.
that all
Wow.
happen. But the interesting thing for me, listening to your presentation, you know, we're used to looking at the IoT market and talking to customers about the energy problem or the battery problem that you mentioned.
Yeah.
Because, you know, if you've got a large network of sensors and they're all operating on coin cell or AA batteries, there's a lot more labor than you would think to go change out those
That's
batteries.
what everybody's told us, right? You know, you get this, you know, people who really have to deal with it have a lot stronger opinions than someone who's sitting in their office thinking theory, you know?
Right. And so that was interesting to hear you say that. One thing I haven't thought very much about, because it's really not our focus, is the data, like you're talking about. We know there's an energy problem. Haven't thought much about the data problem and cost of moving data off device to where it needs to get processed. So, you know, fascinating for me to learn about that.
Yeah, thanks. Yeah, no, it is something that, you know, we thought of, and then I don't know whether it was some sensor guy told us about this or we thought of it first. I can't remember, but you know, you know, I will tell you what's interesting is when you run into people who have like smart buildings and others who use lots of battery powered sensors, you know, like, you know, there's a big company, I guess I can say it in this company, it's Schneider Electric, that wants to build this into the architecture of their next, you know, their next smart building stuff or architecture. And the reason, yeah, they're going to save money on the backhaul, but it's really more about they need to extend the battery life. They see that as a big competitive advantage for them. They don't have to add, you know, more battery power, or they don't have to do anything. They just put us in the stack, and, you know, that, you know, but at the end of the day, what we really need is for them and others to build this in, you know, and it could be something like a PTC building us in, and then it just, you know, is provisioned that way. But it's about the built-in and advanced thing. That's really, you know, important for us. I mean, that's where, I mean, we don't do that, we don't scale. It comes out of that.
And really you will always need to change the battery at some point, no matter how much you compress that data or compact that data.
Yep.
There will always need to be a change. And that's why I look at the two of you in a few years really working together, because the energy harvesting will eliminate the need to ever change a battery again. But there's more and more data that will be required, and you will run out of bandwidth. So putting you two together, it's a perfect storm. It's never change a battery and, you know, send all the data you want. And then somebody even mentioned on the chat that you could put edge computing. So you can, with your codes, do your edge computing as well. And with your energy harvesting, it becomes one of a very amazing, at the end, nobody will need to change a battery, and we will get all the information that we want, when we want it, however we want it.
Yeah, you're right. That is the vision, right? I mean, that is where things have to go. Well, you think about things like there's this guy, this Gartner analyst that I talked to that, he says, look, we count on innovation happening that we don't have any idea what it is. And one of those things is simply the amount of data that it will be generated by IoT, especially as things become more autonomous. There's no way that the network that is in existence now or even being contemplated, the networks will be able to handle all that data. That just means that something has to happen. But they don't know what it is, but they know that something will happen. And it could be a combination of your technology, our technology, some other stuff that nobody's thought of yet, something that's in existence, et cetera. And that's the kind of deal that, just happens. I mean, somebody comes up with something new. I mean, someone came up with a semiconductor and, whatever. These innovations are going to happen, and because they need to happen.
Yeah. So Ryan's going to be doing the whiskey talk on May 4th. I'll make sure you get a link to it so you can actually see it.
Yeah, great. I'd love to see that. Yeah.
I would imagine, Charles, that we'll be talking to some of the same customers, over time. Over time,
Absolutely.
I would imagine there's probably some overlap. We could introduce you to some folks. You could introduce us.
Same
to some
here.
Folks, and
Yep.
Would be happy to work with you that way.
Yeah. Like you'd probably like to meet this Schneider guy, right? I would think.
Yeah, absolutely, for sure.
Right. Okay, sure. Yeah, no, that sounds like a good idea.
Yeah, my brother wow, beautiful. I don't know where you're at, but right over the river, there's a beautiful rainbow.
Yeah, that's where I'm at, Steve. And my
There's
car
a
windows
bundle.
are down. My car windows are down. I might have to jump off for a second because it's pouring.
Oh, yeah. Good idea.
But my brother was a vice president or something of the largest building management company, and I forgot the name of them. And I'm gonna definitely talk with him. He retired about 3-4 months ago. However, he knows everybody still there. So it's building monitoring and so on, petrochemical facilities, a huge, God, I forgot the name of it. But, once again, if we could just find that one customer to, get you rolling.
Yeah, well, that's what it really is. I mean, I think we'll have a couple of customers here in the next couple of months. I'm hoping sooner than that, but it never is what you think. But at the same time, they're so far in it. We've done one of them has this whole vendor intake, fill out 1 million forms, do all this stuff for security and everything. So they've completed all that, and we've negotiated a price. They have a copy of our license, but we haven't yet seen their comments. But they use the same lawyer we do, so I'm hoping they're like so.
Yeah.
So at any rate.
Yeah, it's CBRE is the name
Richard
of
Ellis. Yeah.
Yeah.
CBRE. Yeah.
Yeah. So I'll talk with him. He looks a lot like me. So if some guy who looks a lot like me,
got it.
Things
No problem.
That's who it is.
I'll look for
And
him.
Ryan he's not a relative, but
Right.
we got the same good looking
So
haircut.
I don't have to shave my head, do I? I mean,
part of the cool kid club.
oh yeah, I guess so, right.
Excellent. So hopefully your car wasn't too wet.
It wasn't too bad, but it was raining pretty good. And I saw that rainbow you're talking about, Steve. That
Yeah.
was beautiful.
Yeah,
Well,
I'm in California, so it doesn't rain. Oh, at all. I mean, from basically, like we had a little bit last weekend, but that'll be it until December.
Wow.
Maybe November, but usually December.
Where are you at in California, Charles?
The Bay Area near San Francisco, outside San Francisco.
Gotcha.
So,
Well, excellent. I will get him a link to the whiskey talk, and then
Great.
he can learn all about your technology and kind of
Yeah.
see what you're doing, and
Sounds
maybe
good.
not for a couple years, but in a couple years, you guys will see the value in coming together, and you can
maybe
look
one of
back.
us will buy the other, right? That's how we operate.
There you go.
Right.
Cool.
All right. Well,
Well,
good.
I'm
Well,
gonna
thank
jump
you so
off.
much. Yep. Thank you so much, Steve, for setting this up. It's really great of you. And Shannon, I think she's probably eating her dinner.
Yeah.
But at any rate, I really appreciate that. Thanks for coming on, Ryan. And Mark is one of our guys, Mark Willen. So, hey, Mark.
Okay.
All right.
Excellent.
Well,
Take
good.
care, everyone.
Take care. Thanks.
Bye-bye.
Bye.
Thanks. Bye.